My name is Santiago Nunez-Corrales. I am a research scientist at the National Center for Supercomputing Applications, and my job is to serve as the quantum lead for the organization. That means developing the strategy and articulating projects and developing research pertinent to getting quantum computers into people's hands. In a regular computer, what we call a classical computer, we have ones and zeros as the main entities with which then we perform some operations and then translate that into information based on the problem we're trying to solve. With a quantum computer, we not only have ones and zeros, but any possible combination of those values, and we use the laws of quantum mechanics to make these devices hopefully solve problems that are way too hard for our current computers to do. Some of the most interesting and unique facts about my job have to do with the kinds of collaborations and the kinds of conversations with people on campus. As an example, I have collaborators in physics in which they have taught me to calibrate and understand how a quantum device works. And that kind of mutual understanding, building that vocabulary, is a unique experience. My background originally was in computer science. I was trained in Costa Rica. That's where my undergraduate was completed. After doing my PhD at the University of Illinois, I realized that the NCSA is an incredible place to work, and I knew that I would love to work here, or I would love to work in a place like this one. And I was fortunate to apply to one of the positions, get the job, and then I enjoy working thoroughly here with lots of talented colleagues. At the end of the day, we are first and foremost a land-grant institution. It means that not only my job generates knowledge for knowledge's sake, but there is a social mission and there is also a broader economic mission. Specifically in quantum computing, we are at a point where we need to reach scales of utility. Many of these problems that need strong solutions but are very computationally hard relate to things like climate change, or relate to how do we determine whether a certain procedure in a patient actually made that patient improve. And there's the mathematics behind those problems is what drives the need. And also we are at the state of Illinois is one of the leaders in quantum computing, so it's part of our job to make that remain the case. I am Santiago Nunez-Corrales and I am an Illinois professional.